Sounds like a B movie, and a far-fetched one at that. Scientists are working on cooling the planet using human-made volcanoes, robo-tree plantations, and atmospheric vacuum cleaners.
These are technologies that give us enormous leverage over the planet. It gives humans godlike powers.
But what happens when you mess with Mother Nature? Sudden climate change, disaster, warfare, flooding, and famine. Real possibilities here.
Do we do this geoengineering thing? It's very scary.
I'm Anne-Marie McDonald, and this Doc Zone is all about playing God with planet Earth. Imagine a time in the not-too-distant future when scientists try to mimic the effects of a volcanic explosion in a desperate bid to reverse global warming. Consider a climate emergency so severe that engineers create a sulfuric sunscreen, hoping to stop the melting of polar ice, hoping to turn back the rising sea and prevent the horrific storms that would send environmental refugees running for their lives. If we dare to force the temperature down, are we ready for drought and the possible starvation of millions? Does anybody really know what will happen if worldwide climate engineering projects get the green light? Just think of spraying sulfuric acid across the sky to block incoming heat. Or seeding the oceans with iron dust to trigger massive plankton blooms. This is not science fiction. It's called geoengineering, and plans are on the drawing board right now. Human ingenuity could roll back the effects of global warming. At the same time, it could cause catastrophic damage and spark deadly political conflict.
I can get you a war out of that, like that.
In a secluded cove on the California coast, a few miles south of Monterey, an unprecedented brainstorming session takes place. More than 150 scientists and engineers from 6 continents have gathered to discuss an urgent matter: how to save the planet by intentionally manipulating the climate.
I don't think that I would call it playing God. I would say that I would call it playing planetary engineer. And there's a big difference between inadvertently changing the climate, as we have been doing for the last couple hundred years, to purposefully doing it.
The meeting would have been completely closed. No cell phones, no email, no contact with the outside world. But the scientists and engineers don't want to be accused of a conspiracy. And they know the stakes are so high, they will eventually need help. So they've invited people beyond the inner circle of science, people like lawyers, environmentalists, and disaster relief workers.
If something goes wrong, and I know something will go wrong at some point, we don't know everything. We will do something that will have unwanted consequences, that will cause someone to suffer, someone who did not cause the problem. How are we going to deal with that?
A lot of times scientists want to be in a pure knowledge environment. You know, my job is not to be influenced by the political situation. My job is to expand knowledge. But this is different. This is a battle for survival.
While tinkering with the atmosphere may sound completely over the top, some of the smartest folks in the room at the Asilomar conference argue that it may be our last-ditch hope for survival.
Let me actually advocate doing it more or less now. We might get to a situation where we found that the climate really was going to go haywire. Then cutting emissions cannot get you out of it.
Because even if you could cut emissions to zero immediately, you'd still have to deal with all that pollution that's been building up for 150 years.
Geoengineering is a way to deal with the risk of the CO2 we have already put in the air.
We have to do research to know whether it would work and how effective it would be and what the risks are, and we have to compare that to risks of not doing anything.
We've got a problem. The problem's growing more intense by the day. We know we need to do something, so let's make sure we do the right thing.
It's easy to look at the world and say, well, if only the Chinese weren't industrializing in a high carbon economy, if only Americans didn't drive big cars, then things would be okay and we wouldn't need to worry about all this geoengineering malarkey. But the simple fact of the matter is that we exist in a world where these things are happening, and you can sit there like King Canute and wish the tide back, but it won't turn back.
Geoengineers have come up with two quite different ways to try to save planet Earth. One approach would be to do what a volcano does by blocking out the sun, what scientists call solar radiation management. Another approach is to pull all that pollution out of the sky, what they call carbon dioxide removal.
The CO2 that we put in the air stays there without some technological fix, more or less forever, thousands of years.
The only way to reduce that is to actually suck it out of the air somehow. And this is very similar to the idea of, for example, if you have groundwater pollution or a river that's polluted, that you try to take the contaminants out of the river.
Carbon dioxide removal would seem to be the logical first step to rehabilitate the climate. Ocean fertilization ships, for example, could spread iron particles on the sea. Tiny creatures called plankton bloom and multiply because of the iron dust. They gobble up carbon dioxide and eventually die, and then sink to the bottom, presumably taking tons and tons of carbon with them.
If that algae then sinks to the bottom in some way, then it's being sequestered. So you can't just pull it out of the atmosphere, you have to put it someplace.
But any experiment that might affect the world's oceans would be highly controversial. What if the carbon floated back to the surface and escaped? What if changing the ocean's chemistry affected the fisheries? On land, carbon scrubbers could capture the outside air, including tailpipe emissions from cars and trucks, along with industrial pollution. It would chemically filter out the CO2 for storage deep underground.
Air capture is a very benign technology. And then the part where you have to put it somewhere becomes a part that's called sequestration. So if you use geologic sequestration, which is the most commonly thought of way to do it, then we're pumping it thousands of feet underground into an old saline aquifer or an abandoned oil reservoir, something like that.
Sounds simple, but what if there were no convenient hole to stick it in? What if you had to pipe it long distance over land? What if a toxic dose of CO2 leaked? Nothing about geoengineering is going to be risk-free. So-called robo-trees could be genetically engineered to inhale carbon out of the sky faster than natural trees do.
Artificial trees or enhanced trees, which take in carbon dioxide and produce leaf matter or plant matter from it, stabilize the carbon in that form.
But what would happen to natural forests if we planted millions of genetically modified super trees? Do we solve one problem and create another? Even if the carbon removal schemes all worked just fine, if we salted the oceans, hoovered the sky, and planted scads of robo-trees, and nothing went wrong, it would still take years to see results, and we may not have that much time. Which is why solar radiation management gets so much attention from the scientists, because it would work a lot faster. Jonathan Latham and Stephen Salter of the UK have developed an idea to mimic what the ocean does when waves crash against the rocks. They want to create a spume, a fine, salty mist that would make dull gray clouds above the ocean brighter.
When the sunlight lands on the tops of these clouds, about half the sunlight bounces back into space. If we could find some way to increase the reflectivity of those clouds, instead of 50% being bounced back, if we could make it 60%, then of course the Earth will get cooler.
Engineer Stephen Salter has worked with Latham to design a fleet of robotic ships that would make the clouds brighter. The basic plan was to modify a concept from the 1920s, a sailing ship with rotary sails. Salter's updated design would use the rotary motion of the mechanical sails to suck seawater into a pipe under the hull, where it would be filtered and pumped up through the mast, and then sprayed upward into the low-hanging marine clouds. Theoretically, if the salt particles were small enough, they would make gray clouds brighter and cause them to bounce more sunlight and heat back into space.
The first number you want to look at is what would it take to undo all the thermal damage that's been done since pre-industrial times. We think we could do that with 300 ships.
Making clouds 10% brighter could, theoretically, reverse the warming from a doubling of CO2.
The first bit's a lot easier, and then it gets progressively harder as you go on. So less than 2,000 would allow us to have twice the carbon dioxide with no temperature change.
If 300 robotic sailing ships could cancel the climate effects of the Industrial Revolution, and 2,000 would counteract a doubling of CO2, what's the downside? Well, for one thing, brighter clouds might not rain as much, so there could be a drought problem. And less sunlight on the ocean could affect the food chain. If there were negative side effects, they could simply stop pumping the salt crystals, and it would all rain out in a few days.
All that's being proposed there is that we do what whales have been doing for millennia, just cruising the great oceans and squirting seawater into the air.
A cloud's never been brightened with pumping salt into it. So I do think it's a good idea to try and test out that technology. We want to know whether it's even possible. So that's a very small-scale experiment. You do it for a short period of time in a small, isolated part of the ocean. I don't think anybody thinks that that would have a major impact on the whole global climate with 1 or 2 ships.
But the idea of conducting the riskier experiments outside the laboratory, especially larger-scale tests in the oceans or the atmosphere, will be a very hard sell politically. David Keith thinks we can't afford to wait.
Let's say I want the ability to do this in a serious way in 2040. Doing it in a serious way means you really know a lot about the risks. I think that argument actually says you need to start now doing small field tests and a program that begins us thinking as humanity how the heck we're going to manage the global thermostat.
But even if we start now, the risky business of geoengineering begs more questions than science alone can answer.
If you could control the climate, whose hand's on the thermostat? What if India wants it a little bit cooler and Russia wants it a little bit warmer? How do we decide?
We'll get into a panic, we'll realize climate change has become dangerous, and then we'll immediately start doing geoengineering on some kind of madcap basis without proper research and experimentation, and end up running around like mad scientists with our hair on fire.